Alright, so we're back at home now, again. Not again, hang on. Edit, rewind. Alright, so what I need is I need a way, I was just going to show you something, so I'm not now, stop. Alright, so I've literally just finished editing the video that you guys are now watching, and there's been a lot of requests and people asking about how to build this, if I could film some sort of tutorial for creating it, etc, etc. I will. It won't be this week or maybe next week, as I've got a bit of a deadline to start working on the race car now. So but I thought what I might do is at the end of this video, I'll do maybe a 5-10 minute clip on pretty much just step by step how to build it, but I'm not going to pull all this apart and rebuild it. I'm just going to point and tell you the order I built it in, so you guys can do the same. And then I'll also do a quick rundown on my Cura setting that will be available with the kit. Like I say, the link to the kit to build this will be in the description. And you literally just download it, print it. I'll explain it all in the video anyway. So at the end of this video, there'll be a 10-minute or so clip, and yeah, you can just go from there. And good luck to anyone that wants to build it. And please, if you do build it, send me some photos, pictures. Also, if you don't like something and you modify it, make it better, send me some pictures so we can all grow together. It'd be really cool to get this. Do remember, this is a hobby spec piece of equipment. It is not industrial. I don't think it would stand up to you know, doing cuts all day every day, but at the moment it seems to be working pretty good. So yeah, so thank you for watching. Enjoy the video, and like I say, there'll be a clip at the end. Thank you. Hello, welcome back. So in the last video, I was talking about something that I had made while I was off with my surgery, and I'll show it to you now. It's not complete, I'm still working on it, but so this is it. This is a CNC plasma cutter that I've made. Literally cost a total of about $400 to make, including the electronics, which is a sacrificed old 3D printer that I got for cheap on Marketplace. So I'll go through and explain what I've done and how it works, and we'll go from there. Alright, so we'll start off, I suppose we'll start off with the frame. The frame's just a piece of plywood. Yes, it may catch on fire, it hasn't yet. I will let you know when it does. I 3D printed these ends. I suppose I 3D printed these ends here as well. I brought a piece of aluminium tube from Bunnings. It was, what was that? That was $15 for a 1 meter length. So I got, what, 4 of those. 3D printed these ends here. These are not the first ends I made. The first ends I made didn't work, so this is version 2, I suppose. So these slide. Not at all at the moment because the plasma cutter is hitting the table for some reason, so I'll sort that out in a minute. But they slide backwards and forwards relatively easy when the plasma cutter's not hitting that. They have, as you can see, they have 3 bearings, 1, 2, and there's one on that side as well. That keeps them nice and square to each other. I've only got the 1 feed on one side with 1 stepper motor. Up on top I got the same. I got 1 stepper motor, 1 feed, and this pulls this back and forward. At the moment I am having an issue with this top part actually sitting on the rails, which is causing quite a bit of drag back and forward. So we'll go over home in a minute and redesign that and make some new ones, and we'll solve that problem. Yeah, so pretty much the stepper motor, the rollers for the stepper motors are all from an Ender 3 printer. This is the control unit here. So I just 3D printed my own holder, which holds the main power control unit, the screen, and the motherboard as well. I am going to put this all in a box so it doesn't get covered in dust and stuff. This one here, the stepper motor here would normally be for the Z-axis, so this would normally lift your 3D print head up and down. So I've got that on two micro switches there. One which is obviously the limit switch for the stepper motor itself. You have to have that, otherwise this freaks out. And the other one is set up so that turns the plasma cutter on and off. Plasma cutter it's just a 40 amp plasma cutter that I've got here, and it's just those two pins in there that turn it on and off. So literally I just run the two wires straight to those pins and it turns it on and off, and it works really well. Yeah, I'll show you now the first cut. Sorry, it was taken on my iPhone, not on the GoPro, so the quality's probably a bit subpar. But yeah, I'll show you that first cut now, and yeah. Alright, so also 3D printed this cable chain which comes up to here. This just rolls back and forward with this. It just helps protect the cable. You do get quite a bit of, I suppose, a bit electromagnetic pulse or currency that flies through the air, and it does freak out the board a bit. I didn't think I was going to have such a big problem because everything is plastic, you know, and literally nothing is touching the 3D printer controls that's from the plasma cutter. But I've found that just these wires down here, these wires here, which comes around, which actually plugs into the plasma cutter itself, that has enough just to freak this out. So I have to keep that right up out of the way and bring it all the way up around here and make sure it doesn't touch anything near this, and then it's not really a problem. What I am going to do is I'm going to run some alloy or copper tubing and run all the wires through that, and then I'll earth that back into the main unit there, and that will help eliminate that. So that's the next step. So yeah, so what I'll do now is I'll go home and I will draw up some new parts to run that, and we'll fit them up and see if we can get the y-axis running a bit better. Okay, so the issue I'm having is the top piece of that x-axis is dragging on the rails. So what I need to do is I need to remake that and just put some bearings in there so it sits and rolls along a lot nicer, because at the moment with the drag it's obviously causing resistance and also vibration, which will affect the cuts. So we need to design something that will stop that. So this really is my software of choice, Fusion. It's free to download. So need to just work our way through it. So I've already drawn something up, so I'm just going to go through it pretty much step by step of how I did it. So I start off by sketching out the plate I needed, put a couple of runners down it. Let's see, so in the runners I'll put a couple of bolt holes so I can run some bolts through there. This size here is big enough for
one of my bearings to run through. Then I just moved, obviously I needed to clear these hole spaces out so I can put the bolts through so the bolt heads don't foul on these. I just rounded them up to make them look a bit more presentable. Then I needed to make a bit more strength in here, so I added some walls through there, put a bit of gussets in there just to make it, you know, a bit tidier, curved it up so it looks a bit more presentable. Then I had to put these holes in here and here. That's purely for the belt, so the belt will go through there, wrap around on itself, so then that will pull it back and forward. And that's pretty much it for that. Then I just need to do the same for the bottom, which I've done. Now I've only done bearings on one side on the bottom, purely for a couple of reasons. For the fact that the plasma cutter holder comes out off this way, but also for the fact that that side there, as the plasma cutter is weighted, it will try to tilt it that way. So it's kind of, you could almost say it's kind of like a thrust washer, just to stop it from twisting. So with that on the bottom and the one on the top on the other side, it should stop it from twisting and causing me any grief there. So I go from those two drawings, 1, 2, and then I hit print. Alright, so I go from the drawing, hit print, and then I end up with the same thing. I'll put it that way so you can see. So it's got slotted holes on that side, the normal holes on that side. Bearings will run through the center. It's got the hole there for the belt to run through, and that one's the top one. So here's the bottom one. So, and I also printed a new plasma torch holder, just because I was kind of limited. I was limited with my height adjustment because I made it too long, so I've just made that one slightly shorter, and it had to be slightly narrower to clear that. So now we'll go over and fit it up and do some cuts. Alright, so I've got it all back together now. It's all rolling much nicer now. Next issue I've had is it's hitting my shield. So at the moment what I'm going to do is I'm going to just move the limit switches forward, just to stop that, so I can just make sure everything is okay. So pretty much want it there, I think. Yeah, about a mil play. Perfect. And do this one up. Perfect. So perfect. And same down here. So that's where that hits. So this one here needs to be moved forward. That's by quite a lot too. Alright, now let's plug it in and see if everything's working. Alright, we'll start with prepare access X 10 mil. Perfect, alright. Motion, let's see, auto home. Perfect. Turn it off. Perfect, so that's all, everything seems to be working alright there. Going to fit the plasma cutter now, and then we'll have a crack at doing then I'll pop home and do a design or something that we can just have a test cut on. So I'll do that now.
Alright, so in that last video clip you would have seen it kept on stop starting, and I'm pretty sure at the end it just stopped altogether. So what was happening was the base plate, or the bed that everything was sitting on, was just mesh, and that was bending and warping under the heat, which was causing the plate that I was cutting to be too close or too far away in different spots, and it'll just break the arc. So what I've done to fix that is I've now made a new solid bed for it to sit on, and also I have changed this part here around, so now it's facing that way. I wanted to keep the plasma cutter and everything this end of it, and keep all the electronics that end, purely for the fact that what was happening was I was starting to get a little bit of electromagnetic field from it, which was starting to freak out the computer and making everything shut down. So I've changed it this way around now, and I'll try and do a cut I have on my computer at the moment. I just have a template for this. It's literally just sits straight over there, so I'll fire it up and see how it goes. Alright, so we've got it running. It's going. This here is what triggers the plasma cutter down there. And the cable just goes up and it's just mounted there. So hopefully it will start in a second and I will show you it going. Once this starts to move, that's when it's in its starting away. Alright, so that seemed to work alright. There was the little spot where it hadn't quite lined back up. Not 100% sure what that is. I'm sure I'll figure that out as I do more and more cuts. But the next thing I suppose to do is I've got an actual job for it. One of my mates has it's like a simulator rig seat set up. But it's just a bit flimsy up in the top, so he's asked if I can make him some brackets for it. So I'll draw up some brackets and then we'll see if this thing can cut it out. Kind of give it its first test, I guess. Alright, so I'm having a crack now at doing the first one of these brackets. I would do like 6 or 7 of them and then just have a bigger sheet on here, but I've only put one on here because sometimes when it's doing lots of holes, like lots of stop starts, the plasma cutter can't keep up the next start, and I haven't worked out how to tune that out of the actual software yet, so I'm still working on that. So this is literally going to be a test. It's just going to be a test go, see if it works, and see how it comes out. So this here will start moving, this part here, which is what activates the plasma cutter. This technically on a 3D printer would be the Z height, sorry. And I make it go up and down by doing Z hop settings in my slicing software. So that's what triggers it on and off. Once that starts to move, we'll be away, and we'll just keep fingers crossed and hope for the best. So yeah, so it's just booting up now. Should start any second now, and then we should be away. It'll do a couple like, oh, here we go, we're away now, so. Yeah, so I missed that hole. Alright, so it missed the hole there. I think that might be more to do with the plate distance than anything. So I'll wait for the compressor to turn off and then I'll check what it came out like. Alright, so this is it here. Came out alright. That hole there hasn't quite gone all the way around. But that part there breaks out pretty easy. So that's no worries. So it's literally just that one hole there that was the issue. It was a bit close on the sides, but I think that would clean up alright. I just need to work out why it didn't do that one part there. But there's the cut out of the steel. I need to work out how to turn these little triggers off. I might be able to do that in the startup G-code. I do need to look into that, so I'll get that sorted. But what I might do now is I might turn this around, put it back in the same spot, and try to do that one. So I'll fire this up, because it takes a little while for it to go through its booting up process. I'll get this hopefully back in the same spot again. Let's move it over a touch. There we go. And we'll see if we can get another one. I think these will clean up quite nicely on the linisher. It's just a shame about that hole there. I might have to finish that one off by myself, but yeah, I mean, I'm pretty happy with that. So we'll see how the next one goes. And it's away. So what happened there was the nozzle actually hit the steel, so I'd assume the steel's probably warped up or something, or there could even just be a bit of slag on top of these rails, and so it dragged this off with it. So that's a bit disappointing, but I do have in my mind a plan to make up some clamps which I can use to clamp this down to here to stop it from sliding around. So maybe we'll move on to that one next. Okay, so I've just got some washers and bolts to hold the plate down, but I only had one big washer, so I thought I'll just quickly draw up another big washer so I could do that on the other side. That seems to work so far for now, so I'll keep this one going. Damn it. Ooh, shit. Right, well that one seemed to work. It didn't seem to... Oh, I see one of my bolts actually fell off. Okay, that's alright though. So I need to work out... I think it might have hit it as it came back. That might have been what caused that to fall off. So let's see how this came out. If it's probably... It's a bit warm. So it hasn't quite punched the centre out of it, which is a bit frustrating, but it's not a big problem. The big issue I have is I've just done it as a 6mm centre hole, but my bolts are M8s, but that's not a problem. I'll just drill that out. So yeah, oh, as you can see, came out good. Just the centre's not out yet, but give that a wriggle back and forward. Not quite sure why that's not happening, but there, so yeah, so there you have it. Alright, so just before I wrap up this video, I just wanted to say, if you want to build any of this, the files will be linked down in the description below. Yeah, pretty much all you need is a cheap Ender 3 Pro, or Ender 3, any Ender 3 3D printer really, and some belt that you get from from AliExpress or Trade Me or eBay or whatever your local one is, and some wood and some tube. So I believe you could probably go quite big with this before you start getting a bit of deflection in the x-axis. You could go probably 2 meters before these tubes started to bend on the y-axis, so you could actually build quite a big one. Also, my Cura profile setting for doing this will be in link down below as well. So you literally just import that straight in, and you've got that all sorted. So yeah, so there it is. That was the project that I was telling you about. I designed while I had a sore elbow. Still needs quite a bit of fine tuning. You probably, whenever I use it, working on the GTO, I'll show you using it, and if I got to make changes and stuff like that. But that's pretty much a simple setup. I've got a few things. I've just got to put that in some sort of dust-free box, because the dust and shit, it probably isn't very good for it. I don't know how long these belts will last, because they're just a rubber belt, and with hot sparks coming up, I wouldn't be surprised if they wear out relatively quickly. But yeah, other than that, it all works. And yeah, thank you very much for watching, and I'll catch you next week. Cheers. Alright, so at the start of the video I told you there'd be a bit at the end. So here we go. With this, pretty much I started with a base. I brought this, it was 1200 by 600. You buy it as big as the tubes that you get, pretty much. If the tubes you get are 2 meters by 2 meters, you might need a 2 meter by 2 meter base. It's really up to you. So you start off with your base, then you 3D print these green parts here. That one, that one, that one, and that one. Then you get your tubes and you cut them to whatever length you want your y-axis to be. So for example, I think these ones here are 1 meter long. You literally just slide them on, slide it on, and then screw it to the base. Pretty much I tried to keep this back one as close as I could to the back edge. And then I put the tube inside these ones, inside both of those green ones, and then I measured the tube distance from here to there, and then I keep that distance equal the whole way along. That's quite important to keep that equal, and tried to keep it as square as possible. The squarer it is, the better your cuts will be. And then I screwed them down to the base. So once they're screwed down to the base, next thing you want to do is assemble these two ends. They have they have 6 skateboard bearings in each. And also when you print them, there are washers. I don't know if you can quite see in there or not. There's a washer on each side of the bearing. That's just to help keep it central. Once you've assembled them, you undo pretty much undo that end, roll this on, same on that one, roll it on, screw it back down to where these were screwed, and then you need to measure pretty much from the center of this to the center of that to get your x-axis tubes. Cut them to length. Once they are cut to length, you have to pull these off again and assemble it. So you pretty much put the tubes in. This should be, on my printer, it was a very nice tight fit. If you don't have a tight fit, you might have to put a screw through it to make sure it is tight. Because if it isn't a tight fit, you'll get a lot of deflection on that side, because there's no stepper motor on that side, only on this side. So once you've got the tubes in and these parts assembled, slide them on, screw this back down, and that's your X and Y axis sorted. Then you get yourself a 3D printer. Well, the idea was you'd buy a 3D printer, you build a 3D printer, you print all these parts. All of these parts, I think now you should get away with maybe 1 spool, 1 kg spool. It might pay to get 2, just in case you have errors or problems. But once it's all together, all printed, sorry, you pull your 3D printer apart. This part here is still the original part from the 3D printer. It's just bolted to the extrusion that's on it. That's just the screen taken off, and that's just a power pack taken off. It's the power pack, I'm pretty sure it's just held on by that screw and that screw on the extrusion. That one's just held on by a few screws. Like, there's nothing hard about it. You take it off, pull the cover off, and then just follow the cords that come from the hot end that go down to the motherboard, and you just unplug them. They literally just plug in, plug out. They look a lot like the cords will look like that, and they literally just unplug, and then you're done. Once they're unplugged, you need to pull out the plugs for the hot end and also the plate, the temperature plate. Once they're unplugged, you can set them aside. You don't need them anymore. You could sell them if you wanted to. Same with the hot end. If you don't ever plan on going back to 3D printing with it, a lot of people I've talked to are just going to buy a 3D printer just to do this, so they'll just disassemble it for that. Once that's done, you should also have printed this white piece off here. This here literally just slides onto it, bolts on with a screw there, a screw there. You do have to drill these screws, but the plastic bit underneath does have a hole, a part for it that you can screw and tap. You drill those two holes there and there for where the screen would normally sit. Not the screen, so where it would normally bolt to the extrusion. So they just literally, those holes are already there. And then on that plastic bit, there's a mount to mount your screen. Once that's mounted, you mount that, mount your box, and mount that all to it. That's done. All your cords will come out this hole here. The hole actually has a slot in the bottom, so you just put the cords on the side and run them all up into the slot one at a time, and then once they're in, you rotate them around and they're done. So that's pretty easy. Once that's done, you start to run your cords. This one here is the Y-axis. I did not have to do anything to that cord. It's pretty tight, but I mean, I could move it one way or the other. The rest of your cords, you will have to cut and lengthen pretty much for the length of your bed. Can I suggest, if you haven't done it before, you're not amazing at it or anything like that, when you do it, get your cord like this. Just let me just put you down so I can. There you go. Okay. When you get your cord like this, pull the cords apart, pull the wires apart, because they're all joined together in a ribbon. Pull them apart. Cut that one there. Join it to your new piece of wire. Join that into the other end of the wire, so you'd have a big loop coming around here. And then do the next one. And then do the next one. That way, if you just cut it through there, if you do not get them in the right order, you're going to have a lot of problems. So I did them one at a time. I suggest doing them one at a time. You could probably use a multimeter or something to find out which ones are which, but one at a time works. It's easy, it's fast, you're done. Once you've extended, you need to extend your Y-axis stepper motor and your X-axis stepper motor cords, as well as your X-axis stepper motor cord and your Z-axis stepper motor, XE, whatever you want to call it. Once that's done, you print off these here, which mount onto your tube for your limit switches. There's two of those, and your limit switches will be in your 3D printer. You pull them out, you screw them on using the factory screws, and then you just buy some of these. What are they? Oh, that's a good point. I don't have the box here anymore. I think they're like M4 by 30. Just buy a box of them. They, the box looks something like this. Just a box of those. I'm pretty sure they're M4 by 30s. Or anything that fits through the holes. You can drill the holes out bigger if you need to. Once you've done that, plug your two stepper motors in. Also your X-axis stepper motor and your Y-axis stepper motor. You can fire it up now, and that should all move. This one here should move back and forward. You wouldn't have assembled this part yet. Next up, I would suggest to assemble is the Z. So this here is your it would normally be your Z axis to move it up and down. This here is just a limit switch, and that turns the plasma cutter on and off. These are just 2 micro switches. You just buy them from any sort of electronic store. The inside one here has to be on all the time, and when it's triggered it turns it off. And this one here has to be off all the time, and when it's triggered it turns it on. It's pretty easy. These micro switches, if you can see, have a screw mount there, and another one underneath. So they have 3, and they do both. So if you can get something like these, it'll make life a whole lot easier. And then you just 3D print this. It's a nice tight fit. I did make a hole in it for putting a grub screw, but I've found I don't need it. It seems to run quite fine. And also sometimes if you stuff up on your startup procedure, it'll go all the way around and it'll keep on spinning, and it will slip on that shaft and not destroy anything. So that works out. It works out pretty good. Next up, you need to buy some of this belt. I brought it from AliExpress. I think I brought it in a 5-meter roll. For my table side, which is 1 meter, 1 meter by 500, 5 meters was perfect. I actually had some left over. If you want to go bigger, you might have to buy more. Then pretty much you feed the belt through this hole down in here, which is on this black plastic bit. Loop it round, and then I 3D printed these. These files should be in it too. I think I called them a belt clip. They literally, you slide the belts to the teeth. So I don't know if you can quite see, but so the teeth line up with each other, and then you slide that on, and that holds it. The teeth kind of, the teeth kind of lock together, and so they can't. So it kind of grips itself. So you put that one on, run it down. This part here is just your normal Y-axis idler. It's on your 3D printer. You just unbolt it and just slide it through. The hole on that side should be slightly smaller, so you can screw that in, and it holds it in nice and tight. Run the belt around. It goes over top of those bearings and out the other side. You might have to file that if your printer isn't great with tolerances. And then comes out, goes down around your stepper motor and then back. Then I have this blue plastic clip here, which has also got the file. Run the belt through one side, back, and then another one of these belt clips. That one was black, so I ran out of blue. And then I just run a cable tie to do the tension. So you do it up as tight as you can, then run a cable tie and pull it up a little bit tighter so you get a nice tight belt. Once you've done that, your Y-axis is sorted. Next up, you need to print these, which is top and bottom. More skateboard bearings in each side. These are M8 by 45s, I believe, and I think those ones are M8 by 30s. You run those, put those bolts through. There's bearings inside here, 1, 2, 3, 4, and on the bottom there's 2 on the back. Bolt them on. Do the same thing with your belt. Cable tie, clip, belt clip around the stepper motor, back. I built this thing here at the back to be exactly the same as the Y-axis one, but then I found on the 3D printers that they actually had an M8 style tensioner, so I made these adapters so you don't have to reprint. And then I think on the files there should be some M8 by 1 mil washers that you 3D print. I'm pretty sure that there's just 4 of those on each side to keep it nice and center, and then a bolt going through it. And then the same thing again, tensioner, etc, etc. Once you've done that, pretty much it should move on its own when you use your control unit. Once that's done, this part here is another part. This is called the torch holder. You 3D print that, it bolts underneath, and then you bolt your torch head to it. Once you've done that, I used this on the printer, and I measured the size of the hole I wanted to use. So I went, 500 up, a meter up, 500 across, and just drew a square. Once that square's done, I cut it out and I made just a steel. I made this one just using angle iron. I like using angle iron because it works. I find it works pretty good. The arc just shoots off either side and it lasts pretty well. So that bed is mounted to my plywood table underneath, not actually to this. not actually to the cutted frame. Yeah, so once that's done, you need to measure the height. So this is something I haven't done yet, but you need to measure the height from the bottom of this to the top of your angle line, or you could put a plate on and measure. You need it to be the same the whole way around. Excuse me, I'm trying to talk as fast as I can to keep the time down. Like I say, I will build a step-by-step video later. If it is, say on one corner 50 mil and on another corner it's 49, you need to pack that side up with a 1 mil spacer, because if you don't have spacers, if you don't have it perfectly flat, what can happen is when your arc length changes on your plasma cutter, it can blow out, and then you'll have the problems that you would have seen in my video today. Okay, so once that's sorted, you should have this. Everything should be going. I like to run pretty much a 1 mil gap between my plasma cutter and the workpiece. Speeds and stuff like that you have to work out for yourself. It's really suited to whatever you're cutting. If you look on Google, there are actually plasma cutter speeds and stuff like that you can download. It's just like a little picture that has all your speeds and what you should be running, etc, etc. If I get time, I'll chuck a picture in of that here. If not, that would have looked stupid. And then it's pretty much done. Should be all wired up. You will have your limit switches. So this one here is just wired up to off. Just comes down. It's just a 2-wire cord that I've got, and then down the bottom here I've just got these two here, which are just a couple of pins. They were a female connector pin, because in my actual plasma cutter I just have those. Okay, try to get a good angle out there. Just those two pins, and those two pins, once they're bridged, that's what swaps. That's what stops and starts it. Let's chuck that cord up there so I don't get it caught up on anything. Yeah, I cut a dragon out earlier. It came out pretty good. So yeah, so you just literally run that down to your plasma cutter, and that's what will turn it on. So again, when I show you the Cura settings, it's the Z hop which turns that on and off. So yeah, pretty much that's it. That's a quick rundown. Hopefully some of you guys could build it from just that little video. If not, I will do a step-by-step one in a few weeks probably, so you can build your own machine and have some fun. I will now show you my Cura settings and how I get that to work, and how I get it to trick the machine to thinking that it's printing when really, excuse me, when really it's cutting. And yeah, so we'll go do that now.